Chapter 4. Finally, one of my favorites. This chapter is about angles, the protector triangle and symmetry. Today I will teach you what an angle is in math, the 5 different types of angles we know, and how to calculate the angles between the hands of a clock. So, here we go! Let me start by explaining what an angle is. In chapter 1, I taught you how to draw sidelines. In this situation, if the pedestrian waits in the alley and looks at the trees on the other side, he can't see every tree. By drawing the sidelines, we can determine that he can only see 3 trees. The area between the sidelines is what we call the angle of vision. An angle is a way of telling how big the area is in between the arms. It doesn't matter how long the arms are, so these 2 angles are the same size, no matter how much I extend the lines. Angles are measured in degrees. A circle consists of a total of 360 degrees. Instead of writing the word degrees, we write this symbol above the number. The 360 comes from astronomy. In the old days, as in 500 BC, the Babylonians thought a year was exactly 360 days. This could then be divided in 12 equal sizes, with each month having 30 days. By now, we know a year is slightly bigger, but being off by only 5 days is quite the achievement. In math, we categorize angles into 5 groups. The first one are right angles. In chapter 1, I told you that right angles are perpendicular and we draw this symbol in the corner. The big corner of your protector triangle is a 90-degree angle, so you can always use that to easily check whether an angle is a right angle or not. The second kind of angle are acute angles. These are angles that are less than 90 degrees. For example, the smaller corners of your protector triangle are both acute angles. The third category are obtuse angles. These angles are greater than 90 degrees. So, if you place your protector triangle inside an angle and you have room to spare, it's an obtuse angle. The fourth category are straight angles. A straight angle is an angle that is precisely 180 degrees. This happens when the arms are going in the opposite way, so it kind of looks like a straight line with a point in the middle. The fifth category are angles of 360 degrees. These are called full angles and happen when the angle goes all the way around and makes a full circle. You could say that there is a sixth category, the exterior angle, but in math we always look at the smallest angle between the arms. So instead of saying that this is an angle of 250 degrees, we say that this is an angle of 110 degrees, and thus an obtuse angle. The vertex of an angle is often given a name, so this is angle A, which is an acute angle. I also took the liberty of measuring it for you. Angle A is exactly 50 degrees. But instead of writing angle A is 50 degrees, we write this. We still pronounce this as angle A, so don't let me catch you saying something like LA is 50. Also, do not write a C after the degree sign. We're not talking about temperature, we are talking about the size of an angle. Now that we know what an angle is and in what category a certain angle would fit in, I think it's time to get ready for the next part. The angle in between the arms of a clock. Let's start easy so you know what I mean. If the clock says it's 9 o'clock, the arms are standing over here. That is, unless you use a digital clock, then it would say this. With the minute hand pointing towards the 12 and the hour hand pointing towards the 9, the arms make a right angle. So the angle between the 2 arms is 90 degrees. And if it's 6 o'clock, the arms are making a straight angle, which is equal to 180 degrees. But for other times, the angle is not something you can reach so easily. For example, 1:30. It is possible to calculate the angle between the arms if you take into account the following properties of the arms. The minute hand makes a full circle every hour. The hour hand makes a full circle every 12 hours. Knowing this, we can calculate the following. The minute hand turns 360 degrees every hour, which means he turns 30 degrees every 5 minutes. So when he points towards the 6, he has traveled 6 hours times 30 degrees is equal to 180 degrees from the top. The hour hand turns 360 degrees every 12 hours, so 30 degrees every 1 hour. So when he is precisely in between the 1 and the 2, he has traveled for 1.5 times 30 is 45 degrees from the top. That means the angle in between the two arms is equal to 180 minus 45, which is equal to 135 degrees. One more? Then what about this one? A digital clock might say 7:15 or 19:15 depending on the time of day. We can use the same rules to calculate the size of the angle in between the arms. The minute hand turns 30 degrees every 5 minutes. So with the minute hand pointing towards the 3, he has traveled 3 times 30 is 90 degrees. The hour hand turns 30 degrees every 1 hour. So when it's 7:15, he has traveled 1/4 of that hour, meaning 7.25 times 30, which is equal to 217.5 degrees. That means the angle is equal to 217.5 minus 90, which is equal to 127.5 degrees. We can even take this to the extreme. With a little bit of patience and slightly more skill, you can even calculate the angle between the arms at 820, 5035 or even 542. So be sure to practice this because it might help you in the future. You'll never know when some random pedestrian might ask you what the angle is at the current time. In the next video, I will teach you how to measure an angle and how to draw an angle of a specific size. For both methods, you will need your protector triangle, so make sure you have it with you at all times. And when we've mastered that, I will teach you how to draw a triangle, this time without the use of your compasses, but again with your protector triangle. I hope to see you next time. Bye bye!